Download this code from codegive.com, link in the description below. Stopping unwanted API calls with staletime in React Query, a comprehensive guide. React Query is a powerful library for managing server state in React applications. It provides a robust and efficient way to fetch, cache, and update data, significantly simplifying data management and improving the user experience. One of the core features of React Query is its ability to control when data is refetched based on a stale time. This stale time helps you avoid unnecessary API calls and optimize your application's performance. This tutorial will provide a deep dive into using stale time effectively to prevent unwanted API calls in your React Query applications, along with detailed explanations and practical code examples. Understanding the problem: unnecessary API calls. Without proper caching and refetch control, your React application might make redundant API calls when one component mount/remount * each time a component mounts or remounts. It might trigger a fresh API call, even if the data hasn't changed. 2. Window focus * React Query's default behavior is to refetch data whenever the browser window regains focus. This can lead to numerous API calls if users frequently switch between tabs. 3. Network reconnect ions * When a network connection is re-established, React Query might trigger a refetch to ensure the data is up to date. 4. Frequent updates * If components that depend on the data re-render often, they could trigger multiple API calls in quick succession. These unwanted API calls can overload your server, consume unnecessary bandwidth, and degrade the user experience. React Query's staletime and related configurations offer effective solutions. Key concepts: staletime and related options. Before diving into the code, let's define the critical concepts. Staletime * This is the time, in milliseconds, after which data is considered stale. While the data is considered fresh, not stale, React Query will immediately return the cached data without triggering an API call. If the data is stale, React Query will still return the cached data but will also initiate a background refetch to update the cache with the latest data. Cache time * This is the time, in milliseconds, that data remains in the cache after it becomes inactive. If a query is inactive, no longer being used by any components, React Query will keep the cached data around for the duration of cache time. After that, the data is garbage collected from the cache. The default cache time is 5 minutes, 300,000 milliseconds. Refetch on window focus * A Boolean that controls whether React Query should refetch data when the browser window regains focus. The default is true. Setting this to false will prevent refetches on window focus. Refetch on reconnect * A Boolean that controls whether React Query should refetch data when the network connection is re-established. The default is true. Setting this to false will prevent refetches on reconnection. Refetch on mount * A Boolean that controls whether React Query should refetch data when the component mounts. The default is true. Setting this to false will prevent an immediate refetch on mount if the data is already in the cache. However, it will still use the cached data until it becomes stale and needs to be refreshed. Refetch interval * A number representing the interval, in milliseconds, at which the query should be refetched automatically. Setting this to a value greater than 0 will trigger automatic refetches at the specified interval. Be very careful when using refetch interval, as it can easily lead to excessive API calls. Retry * A Boolean or a number that controls whether and how many times a failed query should be retried. A number specifies the maximum number of retries. False disables retries. Practical example: fetching a user profile. Let's create a simple example where we fetch a user profile and display it. We'll progressively add stale time and other options to optimize the API calls. 1. Setting up the project. 2. Creating the API service. Create a file src/api.js. 3. Initial component without stale time, illustrating the problem. Create a component src/userprofile.js. 4. Integrating the component in app.js. Run the application, npm start. Open your browser's Developer Tools, Network tab. You'll notice an API call is made whenever the component mounts or re-renders. If you quickly refresh the page, you'll see multiple calls. This is where stale time comes in. 5. Adding stale time to prevent unnecessary calls. Modify src/userprofile.js. Now, refresh the page multiple times in quick succession. You'll observe that only the first refresh triggers an API call. Subsequent refreshes, within the 1-minute stale time, will use the cached data, preventing unnecessary API requests. After 1 minute, refreshing the page will trigger a background refetch. You might briefly see the loading state, to update the cache. 6. Controlling refetch on window focus. Modify src/userprofile.js. With refetch on window focus, false, switching between tabs will no longer trigger an API call, further reducing unwanted requests. 7. Controlling refetch on reconnect. Modify src/userprofile.js. Setting refetch on reconnect, false will stop refetching when the network comes back online. You should carefully consider the implications before disabling this behavior, as it might lead to stale data being displayed. 8. Controlling refetch on mount. Modify src/userprofile.js. Setting refetch on mount, false prevents React query from attempting to refetch the data when the component initially mounts, if data is already in the cache. This prevents the flash of the loading state if data is available. Data is considered stale after the stale time and refetched in the background. 9. Global query defaults, for consistency. You can configure default options for all queries using the query client provider. This ensures consistent behavior across your application. Now, the default stale time and refetch on window focus, refetch on reconnect, retry settings will apply to all use query hooks in your application, unless explicitly overridden in the individual use query call. This provides a centralized way to manage your data fetching behavior. 10. Using retry to handle failures. The retry option is useful in environments where network connectivity is unstable or server-side errors are intermittent. Here's how to use it. In this example, *retry 3 tells React query to automatically retry the query up to 3 times if it fails. *the is fetching property is checked and a refreshing message is shown when React query is refetching the data, in the background or after a retry. *a retry button allows the user to manually trigger a refetch after a failed query. Important considerations and best practices *. Choose stale time wisely. *. The optimal stale time depends on the frequency of data updates. For data that changes frequently, a shorter stale time is appropriate. For data that rarely changes, a longer stale time is better. Consider user expectations as well. Users expect relatively up-to-date information for financial data, while longer stale times for user profile information may be acceptable. Invalidation for critical updates. When data changes due to a mutation, example updating a user's profile, you should invalidate the relevant query key to force a refetch. This ensures that the UI reflects the latest changes immediately. React Query provides the query client.invalidate queries method for this purpose. Consider cache time. The cache time determines how long inactive data remains in the cache. If you're dealing with memory constraints or sensitive data, you might want to reduce the cache time. The default is usually a good starting point. Leverage background refetching. React Query's background refetching mechanism allows you to provide a smooth user experience by displaying cached data while fetching the latest updates in the background. This avoids jarring UI updates and ensures that users always see something. Error handling. Implement robust error handling to gracefully handle API failures. Display informative error messages to the user and provide options to retry the request. The above example shows how you can retry after displaying the error. Debouncing/throttling. In scenarios where UI interactions might trigger rapid API calls, example search as you type, use debouncing or throttling techniques to limit the frequency of API requests. Conditional fetching. Use the enabled option in useQuery to conditionally disable a query based on certain conditions. This is useful when you don't want to fetch data until a specific requirement is met. Server-side rendering, SSR. When using SSR, ensure that you prefetch the necessary data on the server and hydrate the client-side React query cache to avoid an initial flash of loading state. Avoid excessive API calls in development. While testing, it's easy to accidentally make many API calls. Consider using mock APIs or enabling React Query's dev tools to monitor API requests and identify potential issues. Code example with invalidation. Let's expand on our example to include a mutation and invalidation. We'll add a button to update the user's email, and then invalidate the query to force a refetch. 1. Create an API function to update the user email. 2. Update user profile.js. Explanation of the invalidation. 1. Use query client. We get access to the query client instance using useQuery client. 2. Use mutation. We use mutation to handle the update user email API call. 3. OnSuccess. Inside the OnSuccess callback of the use mutation, we call query client.invalidate queries, user profile, user ID. This tells React Query to mark the data associated with the user profile query key as stale. 4. Refetch. As a result of invalidation, React Query will automatically trigger a background refetch of the user profile to update the UI with the new email address. Conclusion. By strategically utilizing staletime, cache time, refetch on window focus, refetch on reconnect, and refetch on mount in React Query, you can effectively minimize unwanted API calls, optimize your application's performance, and provide a smoother and more responsive user experience. Remember to choose appropriate values for these options based on the specific needs of your application and the nature of your data. Don't forget to invalidate relevant queries after mutations to ensure data consistency. Always strive to strike a balance between data freshness and efficient resource utilization.